Pressure is a force spread over some sort of contact area between two objects. So we're not talking about pressure in a liquid or a gas right now. We're just talking about objects exerting pressure on each other. And objects exert pressure on each other when they exert forces on each other. So we know forces happen often. There's a force applied from one object to another when they push on each other. The difference between a pressure and a force is that we consider a force to be the total force put on an area. Usually when we push somebody, we've put a total force into that object to accelerate it. But let's say that we now started distributing the force over different areas. So instead of just the force being distributed over the whole area of something, we pinpoint it. We push it with just, instead of like our hand, a full hand, you push with just a finger. If you push with the same force, you can deliver the same force. It's harder with your finger than your whole hand. But if you can do that, if you deliver the same force with your hand versus your finger, what'll happen is you're putting a much greater pressure on it with your finger because the force is all focused on the one point where the hand is spread across an area. And that's the idea of pressure, is it's how much do we distribute the force over an area. And this has lots of consequences because the more we focus a force on a specific surface area, the more focused it becomes, the greater the pressure becomes. And so pressure can define things like if one thing pierces another. It's the reason why a sword is better than a baseball bat for piercing something, is because even though you swing a sword with the same force as you would like a metal bat of some sort or a club, if you have the same mass of weapon and the same force being applied, the difference is that club makes a contact area with your target that's much greater than the sword. The sword edge is very fine. It has a very, very small contact area versus the wide, rounded edge of a club. And so while the club will deliver the same force, it doesn't pierce the object, whereas a sword delivers the force into a very, very small area and so can then pierce that object because the pressure is too great at that area. The pressure increases so much that it overcomes the structural stability of whatever that material is and breaks through it. So pressure defines whether or not one thing can pierce another, and usually it tells you if there's going to be a breakdown of the structure at that point if the pressure is too great. And remember, once again, this is just two objects pushing against each other. This isn't the gas pressure in a balloon or the liquid pressure felt when you submerge in water. And so as far as proportionality goes, I think it's pretty simple to see that pressure and force are directly proportional in the sense that when one goes up, the other goes up, just like the mass and the density. If we have a greater force spread over the same area, so if the area stays the same and we increase the force, we increase the pressure. So it's a directly proportional, direct relationship. When force goes up, pressure goes up, as long as we stay over the same area. But now if we keep the same amount of force, if force stays static and we change the area, what we can see is with area gets bigger, pressure will get smaller. And that is the whole idea of the bed of pins or bed of nails that you've seen maybe physics professors lay on and probably cartoon people in India or something like that uh, lay on. I know at least in Aladdin there was one scene with that where they have a board of nails and they have a guy laying on the nails in the middle of the street. And this is the reason why they have a board of nails and not just one nail. The force has to stay the same for us to talk about how pressure and area are related. And in the case of a person laying on nails, the force is their weight pushing down on the nails. So weight is a force, remember? It's their mass being accelerated by gravity. So it's a force always pushing downwards, and it's the same amount because your mass isn't changing that much, especially if you're just laying down somewhere, you have the same amount of mass. And so that weight force stays static. It's the same weight. You're pushing down with the same force. If you were to lay on one nail, that nail would go into you because there's so much force, all of your weight being distributed over a one top head of or one point, one end of one nail. Whereas if you have many nails, like the bed of nails, your force, your weight is distributed over the top of all those nails. And so the pressure is lowered. There's much lower pressure. And so no one nail has enough pressure to pierce your body. The force you're pushing down with stays the same, but the pressure from those nails is lowered because the force is distributed over a much greater area. So this is the idea of inversely proportional and how it relates to pressure and area.